Hello, this is my lab 1. This lab is about charge tapes for physics 2 at Georgia Tech, and my name is Graydon. So basically in this lab we have different pieces of scotch tape which we are charging, and then we put them near each other and see the distance they move to find the charge. And then a useful equation that we will use in this lab is E equals KQ over R squared, where Q is the charge and R is the distance.
Shape and the computational model will represent this interaction and also perform calculations to determine the charge on each piece of tape. As for assumptions, we have that air resistance acting in the tape is negligible. The long tape can be treated as a point charge. Each U-tape created has the same charge, and that tape is neutral until ripped from the base tape. And then these assumptions allow us to approximate an answer by reducing the calculations to a much simpler scenario. So here we just have a few important fundamental principles that will apply for our experiment. The first is Coulomb's law, our electrical force, and you can see that equation written on the screen. And essentially, what we will conclude from this is that like charges will repel each other while opposite charges will attract. And then for gravitational force, we have to account for this because gravity is also acting on the tape. And then for Newton's second law, we can conclude based off this equation that F net is equal to 0 when the momentum does not change. This will prove to be important when we're analyzing the net force on the tape. And then we also have another expression for F net, which is just that F net equals the gravitational force plus the electrical force. And then written down below, we have a few different main results that we concluded, which are that the two U-tapes are positively charged and repel each other. Then we also have written both the magnitude of the electrical force and the gravitational force, magnitude of the charge on one piece of tape, and then the deficiency of electrons on one piece of tape. So for our experiment, we have the system as the charge U-tapes and the surroundings just everything else. And then we also have that the electrical charge on that tape in the beginning is 0. And then for our process, we have that two pieces of U-tape were created by quickly pulling a piece of tape off the base, which resulted in a charge on the U-tape. The U-tape was determined to have a positive charge because it was attracted to a negatively charged pin. Then tape B was hung by each end on two rulers, and when approached with tape A, tape B began to levitate due to the repulsion of positive charges on each tape. The distance between tape A and tape B was then measured. So here are some measurements that we got from the experiment, and we will use these in the computational model. So here's the glow script code I wrote, and I just inputted some of the experimental data from the last slide onto this code in the constant section, along with just a few other values. And I used some key equations discussed in the introduction section in my code. So here's the equation for gravitational force, which is written right here. Then I also used the principle that based off Newton's second law, since the momentum of tape B is not changing, it's concluded that the net y component of the force on tape B is equal to 0. So the magnitude of the gravitational force is equal to the magnitude of the electrical force. So I put that in my code to solve for the electrical force. Then since that value is now known,